over your adjacent side, which is going to be BE. Okay, so mark your work there. Then, the second one, that is question 1.1.2. Okay, then, but where's got a question? How many of you got 2 out of 2?
I don't know how to do this.
Okay, no, after one.
Right. Then sine A. Now sine A, your reference angle is that one. Okay. Now if you look at this angle, there are 3 actually right angle triangles. You've got a smaller one that's ADE. You've got another one ACE, and you also have ABC. Okay. Yes. It will be 1 for each ratio. Alright, so if I start with the smaller one, ADE, over AE, you are going to have, this is your reference angle, that becomes the opposite side. This is the 90-degree angle, so that will be the hypotenuse, and that becomes the adjacent. So, sine A, which is equal to opposite over hypotenuse, is going to be equal to DE over AE. Okay, so that's the first one. Okay, sine A is also equal to, now if we change the triangle from ADE to ACE, this side here becomes the opposite side. Okay? Because this is the 90-degree angle. Right? Now, it's very important for you to identify 2 things when you've got more than one triangle. You identify your reference angle, identify the right angle. Once you do that, you can be able to identify the opposite side and the hypotenuse. So the third side will be the adjacent side. So because of this 90-degree angle, this side here, CE, becomes the opposite side. And this one here becomes the adjacent side. And then AE becomes, sorry, this becomes the hypotenuse rather. Okay? Let me change that. So this becomes the hypotenuse, because this is the opposite side, that's the 90-degree angle, and this side becomes the adjacent side. Now, if you're writing a test, if you have good colors, then you might need to use different colors. Okay, so we're going to have opposite over what? Hypotenuse. So it will be CE over AC. So that's opposite over hypotenuse. That will be CE over AC. Okay? In triangle BCD. Now, in triangle BCD, I can use trigonometric ratios. I have a hypotenuse. Okay? So, this is my opposite side, which is BC. That's the hypotenuse, and this is the adjacent side. Okay? So I can write there and say, since I need the opposite side and I have got the length of the hypotenuse, if you look at your, go back to your trig ratios, so okay, we have to use what? Sine. Because we need to calculate the opposite side, the hypotenuse is given. So it will be sine, it will be sine D. In actual fact, it's not D there. Okay? It should be sine CDB. Okay? Or you can just give a name to this angle. You can call it D1, that one what? D2. Okay? Now if you say sine D, it's not entirely correct. Because D is the whole angle, it's got 90 degrees. Angle D is 90. Okay, because this is a rectangle. Angle D is what? Is 90. Now you need to distinguish which D are you talking about. Because there are 2 angles here. Yes?
So like if it was in the first, like just said D, wrong.
It's not entirely correct.
It will be wrong, right?
Yeah. It's wrong actually.
So what if you just wrote sine theta?
Okay, this you write sin 30 means you are saying the angle that you are dealing with is 30 degrees. But before you substitute the 30 degrees, the name of the angle is important. Either you can use the subscript, like how I did here. You say sine D1 based on my diagram. It will be sine what? D1. Or you can say sine BDC or sine CDB. It's very, very important for you to learn how to name angles properly. It's not sine D. Please. D is 90. Okay? And D is split into two angles. Angle D is equal to angle CDB plus angle BDA. Yes.
So you see, so we have to say in triangle BCD.
Yeah, you see, as I said, Jan, I think it was this part. This helps the person who sees your work.
Oh yes, 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 yes.
You understand? The person who sees your work will say, okay, the learner is referring to this triangle.
But what if we don't write that?
Then it means you are giving the marker a lot of work to try and figure out what you are doing.
Optional or is it a good habit to write?
Okay, in my opinion, it's a good habit to write this. Okay, it creates a positive perception about your work.
Yes.
Do you know that when we are marking, when we see your work, there's a perception which is created.
Yes, yes.
Okay, I have been to the metric marking center. I know what I'm talking about. Okay? I'm not boasting. I'm not boasting. It's the truth. It's the truth. Listen. When you are marking, perception is also important. Okay? If your work is neat and it's clear, it creates a positive perception.
So it will be lenient.
Huh?
It will be lenient.
Yeah, the marker might end up. Actually, it works to your advantage. That's what I can say. Maybe where you don't deserve a mark, you might end up getting a mark. Alright, let me get on. Sorry, Jan. Let's get on. So sine D1 is equal to this D1 here. Is the opposite over the hypotenuse, so it will be BC over VD.
So I just wrote 3, sir.
Okay?
You're making it
Then we substitute now. Sine 30 degrees is equal to BC, which is I'll just write as BC, then BD is what? Is 3. The denominator there is a 1. Okay? Then you cross multiply. If you do that, you end up getting BC equal to 30 sine, so it will be 3 sine 30.
So, but I think that's opposite side.
3 is fine. 3 sine 30, and the answer that we get will be 1,5.
Units, so units.
Okay.
Units.
Okay, unit case, they are units.
I didn't go in.
Okay?
So see what I did was, I said, therefore, because I say the opposite side, I say therefore triangle either, BC, angle BC is equal to 1.5 units.
No, it's not angle, right? Just say
I never
BC.
had angle, so I said,
Yeah. This therefore BC is equal to 1,5. Alright? So, are you okay with that?
Yes, sir, yes, sir.
Any questions?
No, sir.
Then CD. Now we are still in the same triangle. CD. Now there are two ways of getting CD. You can use theorem of Pythagoras, or you can use what? Trig ratios. But in my case, I'm going to use trig ratios. So I have got a hypotenuse. I have an opposite side. Okay? I need the adjacent side. Now if you look at those three trigonometric ratios, okay, the ones that have got the adjacent side are tan and what? And cos. So you can decide which one you want to use then. Okay?
As I said now, you see, I rather do it same and do BD because they give us that one to do.
Yeah.
So we thought to have a answer there.
Here you are already having two choices. So you need to. So I'm gonna use tan. No, it's my choice. If you use cos, it's fine. Okay? I'm gonna use tan. So I'll say tan tan what? To be tan D1, okay? To be tan D1 is equal to, now the opposite side is BC, the adjacent side is CD. So this becomes tan 30 is equal to BC, which is 1,5
over CT.
divided by CD. Okay? And then you cross multiply, so you end up getting CD equal to 1,5 over tan 30. What answer do you get?
2.60. So 2.60.
Never six random.
2.60.
So two decimal places.
Yes, 5 9.
So, actually, press them.
Oh, okay. I think you rounded it off.
Yeah, but it
I think
didn't say
so.
it didn't six random.
Can you round off correctly to two decimal
They
places?
didn't say it's
2.60 like this.
So they didn't tell us random. So
0.
So it was 5, 9, then around here.
Well, what about the other?
5 9 5
The
5 9
It was 9, so
It's 5 9
Okay, in that
I
case,
got 5 9.
okay, do you all agree? If you take a 6 yourself, I think you're being very hyper.
close.
How many of you got 2,6 here?
So they didn't tell us random. So
What answer did you get?
you don't trust my answer.
5 9.
Why?
I did the wrong thing.
so they didn't tell us random.
Generally, you round off to two
They
decimal.
didn't tell us.
Okay, so then
Okay, so how about 6 0 here?
Yes, so they didn't tell us random.
Ta.
So okay, round this one off.
Get out.
So I just
Yeah.
2,6. Yeah, because you see, it's 2,598. Because of this 8, you add one with the 9, so you end up down with 2.
But sir, so you're telling me we'll get marked wrong if you even do 5 9?
So they didn't tell us.
Well, the memo is strict. You can only be penalized once for rounding off incorrectly. Okay? Generally, you can only be penalized once. In any paper, you're supposed to be penalized once for rounding off incorrectly. Yes.
They didn't tell us.
That's why I'm telling you now that you round off to two decimal places. I think I've told you that. Did I tell you before?
Yes.
No, if the question does not specify, this question was from a past examination question, there was an instruction to round off two decimal places. When you're doing your own calculation, always round off to what? Two decimal, unless it's stated in the question. If it's not stated, two decimal
So
places.
see, we didn't know that we had to round.
Yes, they were.
I just said 5 9.
I said 5.
I don't understand.
Listen, from now on, the general rule, you round off to two decimal places. Unless it's stated in the question. Okay? Right. So we are done with what? C. Right? You all okay?
Yes, sir.
Please, if you make mistakes, learn from your mistakes. Correct your mistakes.
And this was a mistake.
Okay? Right, let's carry on. Now let's find the length of AD. Okay? Now to get the length of AD, I need to apply a bit of some geometry. So I'm gonna write some stuff which is related to geometry. Right? To get AD, I need the length of AE and I need the length of what? ED.
Yes.
Okay? So I'm gonna say BC
Equal to TE.
BC is equal to DE. I'm using opposite sides of a rectangle.
Yes.
Yeah.
G.
Okay? Yeah. We need to know why you are saying that DE is equal to BC.
Yes.
Alright? Then I'm also gonna say this angle, which I called D1 earlier,
I got it wrong.
it's equal to, if I label the angles here, I can have B1, B2, B3. Okay? So D1 is equal to B2 because they are alternate angles. Remember, this is the rectangle, so the opposite sides are what? Parallel. The opposite sides are parallel. So D1 is equal to B2. Okay? So I'm gonna say angle B2 is equal to D1. And the reason here alternate angles, then you state that BE is parallel to CD. Okay. The opposite sides of a rectangle are parallel. Okay, that's a property of rectangle.
But it wasn't shown in black.
What?
It wasn't shown in black.
Oh, yes.
It's a rectangle.
Yeah.
The fact that it's a rectangle means the opposite sides are parallel.
We should practice it.
We should know.
Okay. So from here, you see, from here now, I'm gonna calculate the length of DE. Then I'll calculate the length of. Okay, I also need BE, so I'll say BE is equal to CD. So
That's a form.
BE is equal to CD, and here's the reason: opposite sides of a rectangle.
That's question was the hardest.
Let me warn you, in an examination, if you don't do what I'm doing, you may lose some marks.
So, but then it's only 4 marks.
Okay?
So we can only get 2.
Alright. I'm just telling you that if you don't write, it's better when when you're doing geometry or if you've got a question which involves some geometry, it's always wise to write a statement and a reason. Don't just do it in the head. Because if I were to ask you now how you did your calculation, you can't tell me that you just say, say that BE is equal to CD, so you say BE is equal to 2,60. Where did you get that from? Why is BE equal to 2,60? The reason is because BE is equal to CD, they are opposite sides of a what? Of a rectangle. So write it down. Yes. Right, so from here, now I'm going to say in triangle, let's start at the top. In triangle ABE, okay? In triangle ABE, this is my opposite side. That's my hypotenuse, and this will be my adjacent side. So what do I want to calculate? I want to calculate that opposite side. So I'll use tan, because the hypotenuse is not given. So I'll say tan B3 is equal to, please, I'm writing down based on how I named the angles. Okay? So you can also call this B3 ABE. Angle what? ABE. I hope that your grade 8 and 9 teachers, they taught you how to name angles.
Yes, sir, yes, sir.
Okay? So no one should be surprised about what I'm writing down. Tan B3 is equal to the opposite side, which is AE over what? BE. Okay? Then I'll substitute now, so it will be tan 20 degrees is equal to AE over BE. Now BE is equal to 2,60. Then you divide it, you cross multiply.
So that's 2,60.
2,6. Because BE is equal to CD. We got CD in the previous question. So 2,60 tan 20 degrees is equal to AE. So AE is going to be what?
1.63.
It's going to be what?
That's
Can you multiply this, please? 2,60 times tan 20 degrees. No, this tan 20 needs a calculator.
It's 0.94.
0,94.
Yes, sir. No, 95. Round you off.
Okay? I hope you're rounding off correctly.
So you can adapt, sir.
Then, once you're done, when you've done that, we are not done. I found the length of AE. What's the objective? To find AD. So, the length of, okay, DE, I wrote it here, DE is equal to BC. So here I'll say BC, I'll say DE is equal to BC. So that's equal to what? 1,5. Okay? Therefore, AD is equal to AE plus DE. Okay? AE is equal to 0,95 plus DE, which is 1,5. If you add the two, what you get 2, what?
Is that H?
2 comma 1, that would be 2,45.
Probably would be going down from this.
Huh? 0,95 plus 1,5. What does the calculator say? 2,45.
It's 2.45, yeah.
So this becomes 2,45.
So how do you know?
Okay. So we are done there.
So.
So this question here, my suggestion, where you need to apply your geometry, apply it, write the statements and the reasons.
So, one level.
Scale of
So
five.
this is level 3 or 4.
But I also realize